Hello, this is Ms. DB. In this video, we are going to learn about geometric sequences. This is from Chapter 11, Section 1. Our objectives are to recognize and extend geometric sequences, in other words, to tell whether or not it is a geometric sequence, and if so, write the next few terms, and also to find the nth term of a geometric sequence, so like the 20th term or the 100th term. All right, so here we show the heights of a bungee jumper's bounces. So on the first bounce, they went 200 feet. On the second bounce, only 80 feet. And on the third bounce, it was 32 feet. So it's not the same number being added each time, but it looks like it's the same number being multiplied each time. This is a form of a geometric sequence where there is a ratio that is the same between these terms. So if you took 32 divided by 80 and 80 divided by 200 and found those results, that would be a common number. It would be the same, and that would be R, our common ratio. So geometric sequences can be thought of as functions. The term number or positions in the sequence is the input, and the term itself is the output. So we have term numbers like term 1, term 2, term 3, term 4. Those are like the x values. And then what we get out of that, those actual numbers, those are like the y values, the output. We would read, this is how to find the term of a geometric sequence. And we would multiply the previous term by r, that common ratio. And here's how you read this. You read this as a sub n. And what I'm saying, whoops, sorry, it moved on me. What I'm saying here is a sub, S-U-B, a sub n, and that's equal to a sub n minus 1 times r. So if this is term 2, for example, if n was 2, then you would find it by taking term 1 and multiplying it by r. So you take the previous term and multiply it by some common ratio in order to find the next term. And we just talked about that. So here we're just going to find the next three terms in the geometric sequence. So to do that, you need to find what the common ratio is. So we find that by dividing each term by the one before it. For example, 4 divided by 1, 16 divided by 4, and 64 divided by 16. 64 divided by 16 is 4, 16 divided by 4 is 4, and 4 divided by 1 is 4. So this is indeed a geometric sequence with a common ratio equal to 4. Once you know what the common ratio is, you find the next term by multiplying the previous term by the common ratio. So the next term is going to be 64 times 4, which is something, and then you'll take that answer times 4 to get to the next term. So on the next page here, we'll see this. So 64 times 4 is 256, 256 times 4 is 1024, and 1024 times 4 is 4096. So there are your next three terms in this geometric sequence. Here's another example. This one has fractions, but that's okay. If you divide, now it's a little tricky to divide 1/9 by 1/3, but pick the easier ones. If you take -1 divided by 3, that's just -1/3. If you take 3 divided by -9, that's also -1/3. So you don't necessarily have to even find it for those fractions, but what would 1/3, that's these two right here, 1/3 divided by -1, well, anything divided by 1 is itself, dividing by -1 just changes the sign. So we'd have -1/3 for this part, -1/3 for that part, -1/3 for that part. So even though the first one is a little tricky, you can still find what r is. Once you know what r is, we are going to multiply that by its previous term. So -1/9 times negative 1/3. Now when you take negative 1/9 times negative 1/3, let's write that out. A negative times a negative is positive. 1 times 1 is 1. 9 times 3 is 27. So you get 1 over 27. To multiply fractions, remember you just multiply the two numbers on top to get the top number, the two numbers on the bottom to get the bottom number. And then to multiply 1/27 by negative 1/3, 1 times negative 1 is negative 1. 27 times 3 is 81. And then you would complete this. Negative times negative is positive. So these are going to alternate negative, positive, negative, positive, negative, and so on. And leave those answers as fractions. Do not change them to decimals. Here's the problems on your worksheet. For 1, 2, and 3, you just have to determine if it's a geometric sequence or not. If it's yes, then write what the R value is. If it's no, say what's wrong with it. For example, in number 1, we have 2, 4, 6, and 8. Now, if it's geometric, then 8 divided by 6 will be the same as 6 divided by 4, and that'll be the same as 4 divided by 2. 4 divided by 2 is 2. 6 divided by 4 is not 2. It is 1.5. And 8 divided by 6, let's see, divide 2 into both, you'd have 4/3, right? 2, that would be 3/2. Yep, that one's right. So I would have 4/3 or 1.333. So this one you would say no common ratio. If you do get a common ratio, then you would just say yes, ratio equals whatever it is if you get a common ratio. So if in number 3 you get 1/2, for example, as the common ratio, then you would just fill that in and say yes. You don't have to explain any more after that. In the next few problems, 4 through 7, you are going to find the common ratio and then use that to find the next terms like we just did in the example problem. Let's look at number 5. -6, 12, -24, 48. We need the common ratio and then the next 3 terms. So to find the common ratio, you take this last term and divide it by the one before it. 48 divided by -24 is a -2. And we need to get that every time we divide successive terms. That's also equal to -2. And is 12 divided by -6? Yep, that's also equal to -2. So that is my R value. Now you take the -2 and you multiply it by this term to get the next term. So 48 times -2 is -96. And then you multiply that by -2, which will be a positive something. And then you multiply that by -2 to get the last one. So I'll let you finish it. Now in 7, don't think that it's hard just because it's fractions. Let's find the common ratio. 2 divided by 1. 2 divided by the term previous. Well, that's 2. Let's check. Is 1 divided by 1/2 also equal to 2? 1 divided by 1/2. Let's change this one to a decimal. That's the same as 1 divided by 0.5. And then we can check this on a calculator. 1 divided by 0.5 is indeed 2. And then we can check, is 1/2 divided by 1/4? 1/2 is the same as 0.5, and 1/4 is the same as 0.25. Is that equal to 2? It is. So we do have a common ratio, and our common ratio is 2. And then so our next 3 terms, we're not even going to have to deal with fractions because you're just going to keep multiplying by 2. 2 times 2 is 4, times 2 is 8, and so on. There won't be any more fractions. Okay, moving on. If you want to find a large term, like let's say you want to find the 100th term, we don't want to keep multiplying by the common ratio. To do that, it would take us forever. So this table shows how they figured out a way to figure out what the rule is to get to any term we want. And it turns out that this is the rule that they found would work. This means that a sub whatever term you're looking for, that's what n is the term, will be the first term, that's what a sub 1 is, first term, times the ratio raised to the n minus 1 power. So you have to subtract 1 from the term you're looking for. Now when you do this, you do this part first. You find what n minus 1 is. So if it's the 100th term, you'd use 99. You take that ratio to the 99th power first, then you hit equal, and then you multiply by the first term. If you do it in the wrong order, if you were to multiply the first term times the ratio and then raise both of those to that power, that would give you the wrong answer. All right, so let's look at an example. The first term of a geometric sequence is 500. Well, that's a sub 1, first term. The common ratio is 0.2, that's r. What is the 7th term? That's what we're going to use for n. So we have to identify each of those variables from the problem. Then you write the formula down, and then you replace n with 7, r with 0.2, and a with 500. Now when we solve this, you have to first take 7 minus 1 is 6, and then this is the part that you do first. You take 0.2 to the 6th power, and then you multiply that by 500. So 0.2 times to the 6th power, and then multiply that by 500. So let's look at a calculator, how different the answers will be if you do this in the wrong order. So I'm going to take 0.2 to the 6th power, and that is equal to this number here. Now don't write that down. Keep it on your calculator. You can write it down, but you don't have to. And now I'm going to multiply that by 500. And there's the 0.032 that is the answer for the 7th term of this sequence. Now let's say that you accidentally multiplied 500 times 0.2 first and got 100, and then you took that to the 6th power. That answer is very, very, very different than this answer. So be very sure that you are doing your order of operations correctly, and that is to do the exponents before you do the multiplying. There we go. Here's another example. In this one, they're giving us what a sub 1 is, that's the first term, what r is, and that we're looking for the 6th term. So it's all given. We just plug it into the formula. Make sure that you do the 2 to the 5th first, then multiply by 5 to get our answer of 160 for the 6th term. In this example, they don't tell us anything. They just give us the first few terms of a geometric sequence. So we need to do some work on this one. We need to say, well, the first term I can see is 2. I need to find the common ratio by dividing, and then I can find, oh, okay, the common ratio is -3. So now I'm ready to write the formula. We know that a sub 1 is 2, that's the first term. We now know that r is -3, and n, they're looking for the 9th term. And we plug those into the formula, and we take -3 to the 8th power. Make sure on your calculator you type parentheses around the -3. Again, if you do this wrong on your calculator, you'll get the wrong answer. Watch the difference. If I type in -3 to the 8th power, I get, oh, it did do it the right way. On some calculators, if you did -3 to the 8th power, it would tell you the answer was -651. But if you put parentheses around the -3, let's see, parentheses, -3, parentheses. So that's what it should look like, to the 8th power. It should be a positive number. And this calculator on my computer just happened to work correctly. My handheld calculator would think, if I didn't put the parentheses around it, my little scientific calculator would think that I meant negative, oh my gosh. okay, here we are, negative 3 to the 8th, which is negative whatever that number was. It would tell you to take the opposite of it. So put parentheses around it, and then it knows that that will be a positive number. Then you multiply it by 2, and you get 13,122. And here again is a reminder to use the parentheses. All right, on your worksheet, you have these problems to do, and it's similar to on the examples. There's different ways they can give you the sequence. They can give you all the information, like in number 9, and you just have to plug the parts in. And in number 8, they do that as well. In number 10, they give you the information, but it's written out in word form. This would be a sub 1, this would be r, and this is n. In number 12, they give us a sequence, and you have to find a sub 1 and r and n before you can finish this, and then we'll find a sub 12 at the end. Let's do this one. So a sub 1 would be 5 because that's the first term. Let's find r. So we take each term and we divide it by the one before it. And this would be negative 15 divided by 5. So negative 135 divided by 45, I'm doing it on my handheld calculator, that is negative 3. This one I know in my head, 45 divided by negative 15 is also negative 3, and this one we all know is also negative 3. So r is negative 3. Now n, you just go back to the problem and find what term they want you to find, and that is 12. And now we're ready to use the formula, which is on this page. A sub n equals a sub 1 times r to the n minus 1 times r to the n minus 1. So we need to plug all the parts into this formula. So we want a sub 12, that's the 12th term. We will find that by taking the first term of 5 times the common ratio of negative 3 in parentheses raised to the n minus 1, n is 12. So 12 minus 1 is 11. I did that part in my head. And then we get our calculator out, and we figure out what is negative 3 to the 11th power. So let's find that out. Calculator. Whoops. So negative 3 to the 11th power is that number. And I don't really have to write that down. I can if I want, but I'm going to take, can I write it on here? Negative 177,147. And then I need to take that number times 5, which was my first term, and I get negative 885,735. So this is a good example of why you would not want to have to keep going till you got to the 12th term, like multiply this by negative 3 and this one by negative 3, because they're such big numbers that it's easy to make a mistake when they get so big. So this is our 12th term of this sequence. There's some application problems because geometric sequences occur in real life all the time. So here's one with a ball bouncing, similar to the bungee bouncing at the beginning. And they find r, and then once you find r, you just use the formula and use the first term, so it's really no different. It's just that you have to, pull the information out of a word problem. And they got an answer for that. On your worksheet, there's some problems at the bottom to help review this topic. You only have to do the evens. I copied this, took a snip out of the textbook, so it has the odds, but you do not need to do them. Just do the even problems. You're going to find the missing terms. And then in 26 through 30, same thing. Don't do the odds. You can just do the evens. It's just a little bit more practice. In 26, 28, and 30, it's just say whether or not it can be geometric, yes or no. If it's yes, give the common ratio. I want to look at a couple of these problems, like number 18. So in 18, they only give us 2 problems, but they are right next to each other, so that's enough information to find. They tell you it is geometric, so if you have 2 terms next to each other, you can find the common ratio. In number 18, it's 3. So to find this first term, I would take 6 divided by 3, and that's 2. That would be the first term. And then to get to the next term, after it, you would multiply by 3. So to find terms before it, you divide. To find terms after it, you multiply. And I think that's 54. Yes. So for 18, it would be 2, 6, 18, 54. And then you can check by making sure that times 3, times 3, times 3. Yep, it works. Every one of these is times 3. Let's look at 24. So we don't have this term or this term, so let's figure out what the common ratio is. 9 divided by negative 3 is negative 3, and negative 3 divided by 1 is also negative 3. So to find the terms before this, you're going to take the first term that you know, which is this third one here, and divide by negative 3. That's just negative 1/3. And then we're going to take negative 1/3 divided by negative 3 to get this term. Now let's look at that a minute. Negative 1/3 divided by negative 3. When we work with fractions, we did learn how to divide fractions, and the rule said to change this to multiply and change this to the reciprocal. The reciprocal of negative 3 would be negative 1/3. Now we can use our rules for multiplication. We multiply the numbers on top. Negative 1 times negative 1 is 1, positive 1. 3 times 3 is 9. So this term here, the first term, would be 1/9. That one is probably the trickiest one on here because of the fraction part. And there we have all the terms of our sequence. All right, that's it. If you have any questions, please let me know, and have a wonderful